Okay, this one's part two. And so we made it through question 16, and I realized we actually skipped one. So let me go back to that real quick. This one, number 12, talked about from the top of a high cliff, the ball is thrown horizontally. And so if you were to draw a graph of the kinetic energy versus time, if I throw it, it starts with kinetic energy, and then it's going to quickly gain that as it accelerates downwards. So that's why we have a curve here as it exponentially increases. The rest of this, there's a lot of overlaps. I won't do as long. Sorry, I've gone 11 minutes already on the other video. 17 is a projectile motion question. So you've got your kinematic formulas here. Might look slightly different than the ones you learned, but it's all the same difference. 1 half mv squared is how much initially kinetic energy it has, plus mgh is how much initial potential energy it has. So if I found the kinetic energy at the bottom, it would just be the sum of those two. So that's why I'm adding those together. Here, if I'm trying to get up to half the height as opposed to the full height, then as I gain height, I'm losing potential energy and I'm gaining kinetic energy. So at the halfway point, I would just have half as much kinetic as I had initially when I threw it. It would all be a maximum kinetic at first, which would drop off exponentially. Here, since I'm dropping something into the well and it's going twice as long, if you remember your first kinematic form, or sorry, probably your second one that y'all learned, it would be your 1 half AT squared. So if it's twice as long, if it's 1 half AT squared, it would be 4 times as deep. Since I would do like twice as deep, 2 squared is 4, which makes it 4 times deeper for the distance. On this one, if I want to know the speed of the object, I have to look at the slope. So even though it's a negative slope here, at point J, it's moving the fastest because that's the greatest steepness on the line here. And then on 21, we're missing a question. Here it is. So which part of it is where I'm changing the acceleration because of a changing net force? So points 1 and 4, you can see that's where I have curves, which means I'm changing the velocity. And actually, the force is also changing, which is why it's a curve on a velocity time graph. That's pretty unusual. That would mean you're changing the acceleration, which is called a jerk. And y'all might not have talked about that, but at point 2, you can see the velocity is constant, so that means there's no acceleration. At point 3, it's constantly decreasing, so a constant negative acceleration. And then at point 5, it would be staying the same speed, so no acceleration there. So you can tell a lot of information based on these graphs, and you guys might have a few questions like that, which you'll see on the practice quiz. On question 23 and 22 and 24, these are all 2 correct answers. If Mr. Mixon didn't tell y'all, on the AP test, the last 5 questions are multiple correct, meaning you have to pick 2 correct answers. So on 22, if you're on a spring scale in an elevator, obviously you've had that feeling if you've ever been in an elevator where you go really fast and you might feel heavier or lighter, depending on if you're going up or down. So if I wanted to get a low reading, that would mean I'd have to be moving down really fastward, so I'd feel like I'm floating. Or if I'm going up, but I'm slowing down, as you start to slow down and you're moving up in an elevator, your body wants to continue moving up, but the elevator is slowing down. And so your inertia is going to carry you upward, which means you'll feel lighter, quote unquote. And if you're standing on a scale, you'd actually weigh less for a moment, which that's called an apparent force. In 23, a modified Atwood machine is a pulley with a string over it with like a car or something on the table that moves across and then a weight hanging. You might have done a lab with something like that where you drop the weight and it moves the car across. If you didn't though, if you look at your kinematic formulas, you would have to know the masses of the blocks, otherwise you don't know the force on the system. And then you would have to measure the time in order to determine the acceleration. So that's that same equation we talked about earlier, the 1 half AT squared. Here with our 2 blocks, if we're trying to figure out, oh, that's the Atwood machine for 23. Sorry, I was confused. The block sliding down the ramp, just like at the very beginning we started with, in order to find the work done, mu is the coefficient of friction. You might have learned that equation. But if we decrease the coefficient of friction, which means we make the surface slipperier, or if we decrease the mass, that would decrease the amount of work done because work is equal to force times distance. So we can either lower the force, or we can make it easier to get across the distance with those 2 ways. And then lastly, there's lots of stories you could come up with, and you'll have a couple other examples on the review quiz to practice reading motion diagrams. You can see here the spaces are getting further apart from seconds 0 through 5. So this represents something accelerating, whether it's a runner running out of the blocks and going fast, it could be a car pulling away from a stop sign like I've done here, or I hate squirrels, so it's a rocket attached to a squirrel launched across the floor. Now that's the last of the review. So I realize, as I said, some of this you might have felt intimidated by. but that's just a very brief overview of all the things you might have known from first semester. So what I'm going to do is post some practice questions that kind of use information from what you've done here. It's going to look something like this. And so this practice quiz is set up so that you can take it multiple times. And every time when you get to the end of it and you submit, it will show you which questions you got wrong or right. That way you can go back and try it again. So you can view accuracy, and then it'll show you which ones you got wrong. Now, obviously, I would encourage you to use your review, keep that, and study it so that you can use it on the final. But these questions, every time you take it, the quiz, it will scramble up. So it kind of forces you to learn them. You can take it as many times as you want as you're studying this week, and then you should do really well. Now, not all of these questions will be on the final, but some of them will. So you're going to need to be able to look at them and hopefully understand all of them. And that'll be linked in Classroom. So thank you guys for your patience and for being willing to kind of adapt as we navigate these next few days and weeks. And if you have questions, come down to room 220. I'm here all the time, and I'm happy to help you or answer any questions you might have. Thanks.